will be solving question 8 of GATE Chemical Engineering paper 2021 from the subject of heat transfer. The question is, for a shell and tube heat exchanger, the clean overall heat transfer coefficient is calculated as 250 watt per meter square Kelvin for a specific process condition. It is expected that the heat exchanger may be fouled during the operation and the fouling resistance of 0.001 meter square Kelvin per watt is prescribed. The dirt overall heat transfer coefficient is in dash watt per meter square per Kelvin. And this is an MCQ type of question, and we have been asked to find the overall heat transfer coefficient considering the fouling in the shell and tube heat exchanger. So we know that if a heat exchanger has been running for a long time, then due to maybe corrosion or scaling, it will develop a layer, and that we call it as fouling. So that decreases the performance of cell and tube heat exchanger. So basically this scale adds a resistance to this heat transfer. So if I'm having a clean heat exchanger that is on the start of my operation, when the heat exchanger has been initially used, then the heat transfer coefficient, then the heat exchanger would be much faster as compared to when the scaling has happened. Okay. So for the resistance due to scaling, we have the formula as, so let's just write this R as resistance due to scaling is equal to 1 upon heat transfer coefficient of the fouled heat exchanger minus 1 upon heat transfer coefficient due to of the clean heat exchanger. Okay, so this is my resistance and these are my overall heat transfer coefficient for clean HE and for the fouled heat exchanger. And here we have been asked to find the dirt overall heat transfer coefficient, that is this we have to find. And here we have been given the fouling resistance of 0.001 meter square Kelvin per watt. So we can write this as 0.001 is equal to 1 upon UF minus 1 upon the clean overall heat transfer coefficient is 250 watt per meter square Kelvin. Okay, so we can write this as, okay, so this will become 0.004 UF will become 1000 upon 5. So this is 200. So my dirt overall heat transfer coefficient in this case is 200. So you have to remember this basic formula for the calculating the resistance due to scaling. And from the given options, we can select this 200 as our final answer, 200 watt per meter square.